today you'll be solving quadratic systems using 3 different methods. And like when we solve linear systems, our methods are going to be graphing, substitution, and elimination combination. And so for our warm-up, I want you guys to solve the system by substitution, and then solve the system by elimination or combination, whatever you want to call it, and see if you can recall the process. If not, pause it right now and go look it up in your old notes, because this is going to be essential to understanding today's lesson. So, solve by substitution. Because they're both equal to y, it's the easy one. We just set them equal to each other. So we take 2x plus 4 equals 3x plus 2. Get x's on one side, numbers on the other. So let's minus 2x to both sides, and then minus this 2. So that when we have these cancel, and we're simply left with 2 equals x. We found our x. However, when we solve the system, we're looking for an ordered pair. So now plug your x back into an equation and solve for y. Y equals 2 times x, which is 2, plus 4. 4 plus 4, y equals 8. We have both halves of our ordered pair. Write it as together then. So we have our solution is 2, 8. Your final step is to check your answer. You can go ahead and do that on your own. Same thing, moving forward, solving by elimination or combination. We're looking for that final solution of an ordered pair. Make sure everything lines up. So our x's are lined up, our y's are lined up, the equal signs and our constants, or just the numbers, are all lined up. So we're ready to go. So we're going to put the line underneath. So we also need to look for opposites. Notice our y's, we have one positive, one negative, so we have our opposites. So now we go ahead and add our two equations together. So we have x plus x, or 2x. Y minus y, which is nothing, they cancel, equals 10 plus 8, 18. Divide by 2 because we need to solve for our x. And we get x equals 9. Once we have our x, we need to then, just like last time, take it and plug it into an equation to solve for y. We'll just choose the top one. So we have 9 plus y equals 10. You can solve algebraically, or I can do this just looking at it. We all know 9 plus what is 10? Obviously, it has to be 1. Y equals 1. And then our final answer will be our ordered pair. 9, 1. You want to make sure you check your answers, and if you do so, it will work out. Continuing with a review, just to refresh ourselves, we have 3 types of linear graphs, systems of linear graphs. In our verse, we have 2 lines that cross. So remember what those are called. They are called intersecting. Intersecting lines. This point where they intersect is our solution. So how many solutions? 1. Next, we have parallel lines. Parallel lines never, ever, ever cross because they don't cross at all. They have 0 solutions, or none. And our final, there's actually 2 lines here. Notice 2 equations, but 1 line, so they're called coinciding. And coinciding lines have many solutions since they touch in every single spot. And so we have 1 intersection point, no intersection point, and many intersection points. So how do we know the number of solutions? By the number of intersection points. And this is going to be beneficial to you today as we go about solving nonlinear systems. So as I said earlier, we're going to be solving quadratic systems, which are also referred to as nonlinear systems. And our systems will be solved using graphing, substitution, and elimination. if we take a look at our first graph, we need to figure out how many solutions are there. Remember, previously we said that solutions come from the points of intersection. And so we have our parabola in blue, and then we have a linear line in red. Notice we have intersection points here and here, which means those are both 2 points that are solutions to our system. So we have 2 solutions. In our next image, we have our parabola in blue, and we have our linear equation in red. Notice they do not intersect at all, and so because they don't have any points that are in common, they have 0 solutions. And in our third graph, we have our parabola in blue, right there, and then we have a line in red, and here they only intersect at this one single point. However, that is a solution then, since it satisfies both equations, so it has 1 solution. And these are the different possibilities we'll be working with today. Not the only ones, but for today, that's all we'll be having.